Assalamualaikum. This is the fourth class of sampling and estimation, and today we're going to just summarize the topic, and also we will do the we'll find out the sample proportion. I mean the confidence intervals for the population proportion. Okay, so let's start with the summary of the whole thing. What is a random sample? We know that a random sample of size n is a sample chosen such that every member of the population has an equal chance of being selected. This I've emphasized a lot in the last class or the previous classes. Another thing is that every possible sample should also have an equal chance of being selected. Okay, so if you are selecting, for instance, if you have the overall population of 50,000 people and you are selecting 10 samples of 100 each, then every sample should also have an equal chance of being selected. So yeah, apart, obviously every member should have an equal chance of being selected in the sample, but then every sample should also have an equal chance of being selected. Is this point clear?
Yes.
Okay, then they are saying distribution of the sample mean. If a large number of random samples, each of size n, are taken from a population X with mean mu and variance sigma square, the sample mean calculated for each sample, then these form the distribution of the sample mean. That means if you have samples of size n, okay, different samples of size n, the mean of each sample, if you calculate, and then you calculate the distribution of the sample mean, that will be the that is actually called the distribution of the sample mean. Okay, now out of the distribution of the sample mean, you can find out the mean and you can find out the variance. Okay, the mean of the sample mean is going to be the same as the population mean, but the variance of the sample mean will be the actual population mean divided by the sample size. This we've done already. Okay. Acha, if X is normally distributed, now irrespective of the sample size, if if X is normally distributed, then obviously the mean distribution of the sample mean will also be normally distributed. The mean will be the same, and the variance will be actually divided by n. Is this point clear?
Yeah.
So if every X value is normally distributed, the sample mean will also be normally distributed. Okay. If X is not normally distributed, then you apply the central limit theorem. What does the central limit theorem tells us? It tells us that when the sample size is large, in this book they are saying greater than or equal to 30. In the other book it's saying greater than or equal to 50. But I think greater than or equal to 30 is a valid number. So yeah, so if the sample size is greater than or equal to 30, then you can approximate any distribution, either it's Poisson, it's binomial, whatever, to be a normal distribution. And obviously in that case, the distribution of the sample mean will be the same as the population mean. And the variance is going to be the sample mean can be considered as the population mean, but the variance will be divided by n. Okay, this we've done. And then we have also learned how to find out the unbiased estimates of the population mean and variance. We have learned that the population mean is denoted by mu and the sample mean is denoted by x bar. Population variance is denoted by sigma square and sample variance is denoted by s square. The formula of population mean and sample mean is exactly the same, which is this. Okay, variance, the formula is going to be either you use this, but I have taught you to use n upon n minus 1 and the normal formula, which is summation x square upon n minus the mean square. Okay, so either you use this, or if you want to simplify this is very simple. If you notice, if you multiply n upon n minus 1 by each of them, n will be cancelled out and you'll be left with summation x square here. N minus 1, we're keeping it outside. So we're multiplying both the terms with n now. When you multiply this by n and n will cancel out, and there's an n in the denominator here. So that n will also cancel out, leaving 1 upon n minus 1 outside. So if you want, you can use this, or if you want, I think this is better because we are familiar with this formula. So you just have to multiply it with the value of n divided by n minus 1. Okay. Now, for finding out the confidence interval, the formula used to remain x plus minus the value of z. And I have told you how to find out the value of z. For instance, if it is a 95% confidence interval, we used to keep the central 95% of the area. Now subtract this from 1, you get 5%. So divide it equally into two parts. So this becomes 2.5 and this is also 2.5%. Now
Then
2.5 plus 95 is 97.5, which is 0.975. So you can find out the value of the Z with the calculator or with the normal distribution table. Okay, and then finally we had to find out the formula to find out the width of the thing, width of the confidence interval. That is 2 multiplied. In this, we don't keep the mean value of mean. 2 multiplied by 1.96 upon standard, the sample variance obviously divided by the value of standard deviation upon n. Or you can take it to be the variance then, but in that case, you have to keep the whole thing in the square root. Okay, now the last thing which is left. Now, I don't want to go into a lot of examples. We'll do questions from the past papers directly. Okay, which are here. Okay, it says provided the sample size n is large, the distribution of p is approximately normal, where p is n, p here, pq upon n. That means this is the probability of success, p is probability of success, and q is the probability of failure. Here, the mean is going to be p only, okay, and the variance is going to be pq upon n. Okay, if you're finding out the distribution of the population proportion. Okay, so this is very, very simple. If I say, let's take a very simple example from here. For instance, if I take the first question. Okay, it says the manager of a video hire shop wishes to estimate the proportion of videos damaged by customers. He takes a random sample of 120 videos and finds that 33 of them are damaged. Find a 95% confidence interval for the true proportion of videos that are being damaged when hired from this shop. Okay, first of all, what you're going to do in this case is that you will write down the proportion. So what is the proportion? The proportion here is, well, when you define the variable, okay? So when you define the variable, you're going to write let x be the proportion of videos damaged by the customers. Okay, then you're going to simply do what? You're going to write down what is the proportion of the sample. This proportion which they have mentioned is out of a sample of 120 videos. So yes, the proportion of the sample is 33 out of 120 is damaged. So Q of the sample or the failure would be 1 minus 33 upon 120, which is actually 120. 87 upon 120. Okay. Now, in order to find out the, we know n in this case is 120. Okay. So, we will say x is, the formula for the proportion of the sample would be plus minus the value of z here. And here we're going to write down the variance, which is pq upon n. This is how you're going to find out the confidence interval. I'm just writing down the formula here. Confidence interval, okay, for P. This is the formula for the population proportion. This is always going to be the formula. Previously, we used to do what? Confidence interval for the mean. If you compare this with the confidence interval for the mean, it used to be x plus minus z. Standard deviation, the variance upon n. Okay, na? In place of x, we are writing down the population proportion. In place of the variance, we are writing PQ here. Is this clear? If you compare the two. Okay, now you write down for a 95% because we want to find out the 95% confidence interval. Phi of z should be equals to, because we know if this is 95%, this is 2.5%, so overall 0.97%, 975%, equals to 0.975. So z is going to be, let me just take it out from the calculator. 1.96. Okay, 1.96. Okay, so we're going to write 95% confidence limits. Okay, the formula will be sample proportion plus z. Z ki value we know is 1.96 here. Okay. P of S, Q of S upon N. Okay, so let's plug in the values. 33 upon 120 plus minus 1.96. Okay, we have to multiply 33 upon 120 by 87 upon 120 in the numerator. 33 upon 120 into 87 upon 120 divided by 120. Is this here? Can you hear me?
Yeah, I can hear you.
Because I actually I can't hear you.
Oh, you can't hear us. I think I'll speak a little louder then. Maybe that's why you can't hear me.
Maybe. Okay, this is coming out to be 0.199 divided by 120 in this one. So 0.0407. Okay, so this is plus minus multiplied by 1.96. 0.079. 90. Okay, and this is 33 upon 120, which is in decimals. 0.275. Okay. So you just have to simply add them up once, subtract them and write it here, add them up and write it here. Okay. This is 0.1951. Okay, and this will be 0.275 plus 0.07990. 0.3549. So three significant figures. If you want to give the answer, then it should be 0.95195, 0.355. Okay. Let's take another example.
Wait, can you go back to the end of that answer?
Which one?
The
This one?
one we're just doing, yes. Just the last part.
We are doing the confidence interval for the population proportion right now. इससे पहले हमने क्या किया था? Confidence interval for the population mean. Abhi we are doing population proportion. That means instead of mean, if they talk about population proportion and if they give the proportion, that means how many out of how many in the sample. ठीक है ना? So we have to use this formula instead of using the mean wala formula. Okay. I'm doing the fifth question. Okay, explain what is meant by the term random sample. Okay, shall I write it down or just tell you verbally? It says a random, obviously you will write a random sample is the one in which every element will have, every member of the sample will have an equal chance of, every member of the population will have an equal chance of being selected. Okay? And you can also write another one, and that is where every sample will also have an equal chance of being selected. Okay? Random sample bola hai na? Where every sample will have an equal chance of being selected. Okay? In the second part, is this clear?
Yes.
In a random sample of 350 food shops, it was found that 130 of them have special offers. Calculate an approximate 95% confidence interval for the proportion of all food shops. And I've noticed that in all these questions, they use the word proportion. Okay, na? So that we get to know that instead of using the mean value formula, we have to use this formula. Okay, calculate an approximate 95% confidence interval for the proportion of all food shops with special offers. First of all, you will write let X be the proportion of shops with food offers, with special offers. Okay. Then proportion of the sample is going to be 130 out of 350. Okay, Q is going to be 1 minus 130 upon 350. That means 350 minus 130 upon 350. Okay. For 95% confidence interval, phi of z is going to be 0.975. So z is going to be 95 पे हमने अभी 1.96 निकाला था ना. I think this is 1.96. Okay. 95% confidence limits. The formula is plus minus the value of z pq upon n. ठीक है ना? Okay, the proportion here, I'm just changing it into decimal, 130 upon 350. 0.371. 371 here, and 1 minus this answer is 0.629. Okay, so it's going to be 0.371 plus minus 1.96 square root of 0.371 into 0.629 divided by 350. Zero point 0.258 multiplied by 1.96, which is giving us 0.371 plus minus 0.0506. Okay, so once you have to add it, once you have to subtract it. 0.421 here, 422, and 0.371 minus 0.0506. 0.320. This is the interval. Okay, na? So we are done with the first part. Second part. This was the second part. Estimate the size of a random sample required for an approximate 95% confidence interval for this proportion to have a weight. Okay, let's do this part now. Estimate the size of a random sample required for an approximate 95% confidence interval for this proportion to have a width. If you remember, the width formula was 2 times z into pq upon n equals to the width. Okay, so I'm using this formula. 2 multiplied by 1.96. PQ will take the same values, obviously. So 0.371. Are you getting what am I doing?
Yeah.
Upon n equals to 0.04. Okay. This just have to solve it and you'll get the answer. I'm multiplying these two and dividing it by 0.04 first. 2 times 1.96. 0.04 divided by the answer. So it's square root of 0.371 into 0.629 upon n equals to 0.010204. Okay, squaring both sides. Okay, it's going to square this number, which is 1.0412. Okay, I'm multiplying 0.37 by 0.629 now, which is giving me 0.233. Cross multiplying 1.0412 n equals to 0.233 divided by 1.0412. एक मिनट. I think I done some calculation error because the answer is coming out to be 0 point something. Okay, so that is not a valid answer. Let me just check the calculation quickly. Okay.
Yeah.
2 times 1.96. Oh, I'm so sorry. This was not 1.0412. It was 1.0412 multiplied by 10 to the power minus 4. So it's going to be 0.000104123. Okay, now I'm going to multiply. Okay. Divide this answer by 0.233. It's 2237. N is equals to 2237.7. So you'll write N equals to 2238. ठीक है बेटा?
Okay.
ये अगर n 2238 आ रहा है, these are 4 significant figures, so you can make it into 3 significant figures. ठीक है? I hope this is clear.
Yeah. Mm-hmm.
A few more questions on population proportion, 1 or 2, maybe 3. Let's see. So I've taken the first page and I'm doing the second page. You
Okay.
tell me which question to do.
Okay. I think 8.
Okay. 8. We have another page after this, huh? One
Yeah.
more or?
And yeah.
Yes, yes. 8 and?
I'm gonna say 11.
Okay. Okay, let's do 8 first. It says in a random sample of 70 bars of just a minute. Lux Clean soap, 18 were found to be undersized. ठीक है ना? Calculate an approximate 98% confidence interval for the proportion of all bars of these soap that are undersized. देखो इन्होंने proportion का word use किया हुआ है वैसे भी हर question में use किया हुआ है. सही है, so you will write let x be the proportion of undersized soap bars. Okay. Now, okay. So we have to write we have to write down the proportion of the sample, which is 18 out of 70. Okay, so QS is going to be 1 minus 18 out of 70, which is 52 upon 70. Okay. Now for 90% confidence interval, phi of Z is equals to, obviously this is 90. This is 5 and this is 5, so 95, 0.95. So Z equals to, I'm just taking out the value with the calculator, 1.645. Okay. Okay, for a 90% confidence interval, like आप यहाँ लिख दो 90% confidence limit. Z के बजाय आप चाहो तो यहाँ पे 1.645 नहीं लिख दो या next step में लिख दो. Okay, so it's going to be, अच्छा, I'm changing both of them into decimals here for my convenience. 80 divided by 18 divided by 70, which is 0.257 here. And 1 minus this answer is 0.75743. Okay. So 0.257 plus minus 1.645. 0.257 multiplied by 0.743 divided by the overall 70 bars. Okay. So you just have to solve it and you'll get the answer. Okay, but I'm not solving it. Why waste time on this?
Okay.
But you know how to do it. Okay, then they're saying give a reason why your interval is only approximate. Ji. Because we are 90% sure. Okay, we are 90% because this is the probability that the sample proportion will sorry, 8 minutes. Okay, the proportion will lie within these limits is 90% actually. Okay, so it is approximate because we are 90% sure. We are not 100% sure. Anything which is not accurate, obviously the percentage is low. So if it is 90% sure, that means it is an approximate value. It's not an accurate value. Okay. The probability is 90%. No, it's not 100%. If it is 100%, then we can't say that it's an approximate value. Then it's not an estimation. It's just an approximation. Why? Because the probability is 90%. That's why. You said 11 as well. I'll even show you what have they written in the answer.
Yeah.
11 पढ़ते हैं पहले ये कर लेते हैं फिर in order to obtain a random sample of people who live in her town, Jane chooses people at random from the telephone directory from her town. Give a reason why Jane's method will not give a random sample of people who live in the town. G. There may be some people whose numbers are not there in the directory. Okay, or maybe people who may not have a phone at their place. There may be people who are living in the town, but they do not have a telephone system at their place. Is this true? That's
Yeah.
The next part. Jane now uses a valid method to choose a random sample of 200 people from a town and finds that 38 live in apartments. Okay. Calculate an approximate 99% confidence interval for the proportion of all people in Jane's town who live in apartments. Okay, so this is very simple. So let X be the proportion of people in her town, Jane's town, who live in apartments. Okay. So phi, पहले आप proportion लिख दो. Proportion of the sample is out of 200 people, 38 people. And Q of S is going to be, okay, 38 upon 200, I'm doing it directly, will be, I think, 19 upon 100, which is 0.19. And this will be 0.81. ठीक है? अच्छा, phi, बल्कि आप यहाँ लिखो for a 99% confidence interval. सही है? Phi of Z equals to 99% here, meaning 0.5 here and 0.5 here. So this is 0.995. This is coming out to be 2.576. Okay. 99% confidence limits. Formula लिखेंगे. Proportion of sample plus minus Z value upon proportion of sample and upon n. ठीक है ना? It's going to be 0.19 plus minus 2.576. 0.19 into 0.81 upon 200 people. Okay, so this will be the answer for this part. The next part actually we have to do. Jane uses the same sample to give a confidence interval of width 0.1 for this proportion. This interval is an X% confidence interval. Find the value of X. Okay, so let's do this part. She uses the same sample, meaning the value of N will remain 200 only. To give a confidence interval of width 0.1. Okay, what is the formula for width? I'm writing it here. Width is going to be 2 multiplied by Z. Okay, this is the formula for width. So 2 multiplied by, we don't know what percent here. So let it be Z only. Same two values I have to multiply 0.19 and 0.81 here. Divided by 200 equals to the width the 0.1. Okay, I'm going to first calculate the value of Z. Okay, so I'm calculating that. Okay, it's coming out to be 1.8 something. 1.802. Okay, phi of. Acha, now look here. The width is 0.1. So if the Z value is 1.802, that means here the Z value will be negative 1.802. So if I find out phi of 1.802, let's find out the percentage from the table. Shall I use the table or shall I use the calculator?
Use the table.
Okay, 1.802. Okay, 1.802. Fine, you have to take this value, add 1 to it. No, add 1 to this. Huh? So 0.9641 plus 0.0001. Okay, 0.9642. 96%. 0.9642. Did I say 9642 only? I forgot.
Yeah.
Okay, that means this value. Okay. Now, there are two ways of finding out the percentage here. I'm giving you both the methods. Method number 1. We know this whole area is 0.9642. So yeah, subtract it from 1, you will get this area. Okay? You will get this area multiplied by 2, subtracted from 1, you will get the middle wala part. Okay? So 1 minus 0.9642 is giving me 0.0358. This is 0.0358. Multiplied by 2 and subtracted from 1. Giving me 0.9281. 0.9281. 92.8%. ठीक है बेटा?
Okay.
I think यही मेथड ठीक है. हाँ, बल्कि आप ये कर सकते हो, जब आपके पास 0.0358 आया, subtract 1 minus 0.9642 is giving you this. So from this answer, you subtract 0.0348, you will get this answer. That means 0.9642 में से आप 0.9642 में से आप 0.0358 को minus कर दो. You will still get the same answer. ठीक है? That's one understand. You understand the second method? Once you know this part is this, so from this whole 0.9642, you subtract this, you will get the middle wala part, which is 92.8%. So let's check the answers. This is question number 11 and we did 8 as well. So let's find out the answers. We've done 8 and 11 of this. हमने लिखा था 92.8, they've written 93, two significant figures. Did they say two significant figures? Did they mention? They didn't say it. So you can write 92.8% also. You can, I don't know why they have made it into 93. It should be three significant figures. So, okay, fine. Question number 8. We did the 8th one.
Yeah.
Did we have to check anything in this one? I don't remember. Okay, this is the 8th one. Okay, so we had to find out the limits. Give a reason why your interval is only approximate. Because the distribution is approximate. Normal ko binomial pe lekar gaye is wajah se. They've written this. For this was actually binomial now because sample size is known. So yeah, so since you have approximated to normal, that's why it's an estimated answer. Okay, so here I was wrong. Instead of using that, instead of saying that, you have to say, since this is an approximation to normal, binomial approximation to normal, that's why it's an estimated answer. ठीक है बेटा?
Okay.
Okay, there's just 2 pages left here. Just go through it. If you think that there's nothing which I should do from you, then we can just see we'll search out the difficult questions of the rest of the exercises. Okay, just check for 12 till 19 here. I'm also checking. Let's see if there is something which is difficult.
I think 15.
Okay, let's do 15 then. A die is biased so that the probability that it shows a 6 on any throw is P. In an experiment, the die shows a 6 on 22 out of 100 throws. Find an approximate 97% confidence interval for P. Okay. So let P be the proportion of getting a 6. Okay, so proportion is going to be 22 out of 100, proportion of the sample. Is going to be 100 minus 22, 100 minus 20 is 80, so 78 upon 100. Yeah. This is 0.22 and this is 0.78. Okay. For a 97% confidence interval, phi of z should be equals to 97, meaning 3 left, 1.5 here. 98.5, meaning 0.985. So z is 2.17. Okay, 0.22 plus minus 2.17 into 0.22 into 0.78 upon 100. Okay. We will get the answer for the first part. Second part. Saya, I hope you understand.
Yeah.
This was simple. Next part. The experiment is repeated and another 97% confidence interval is found. Find the probability that exactly one of the two confidence intervals include the true value of P. ठीक है, out of the two exactly one, that means अब binomial लगा दो 2C1
Okay.
out of 2 1, ठीक है ना? So whatever is the क्या था, find the probability that exactly one of the two confidence intervals include the true value of P. P is going to be 0.22 here, 0.78, which is 1 year and 1 year. Can I just quickly check my answer? ठीक है ना?
Yeah.
ये I just a minute. Point 22 into 0.78 into 2. 0.3432 आ रहा है. 3432. Okay. Point 97 इन्होंने लिया है. 97. अच्छा, the chance is 97% confidence interval था ना, तो यहाँ पे 97, हाँ 0.97 और यहाँ आएगा 1 minus 0.97 which is I think 0.03. Make sense? Repeated and another 97 compound, find the probability exactly one of the two confidence intervals include the value. So there is a 97% chance, ठीक है ना?
Okay.
Because 97% confidence interval का मतलब ये है कि there is a 97% chance that it will include. So obviously probability of success will be 0.97 and failure will be 0.03. ठीक है?
Okay.
So this will be the answer. 0.0582. ठीक है बेटा? अच्छा,
Okay.
we've got 5 minutes left around. ठीक है? We can do one more question. Have a look at the last page, page 20. Because today I have to go to school, na? So 10:35 I have to leave from home. So I have to get ready and my maid also comes. So I have to talk to her and everything. So it's a very short time for me today.
Okay.
Otherwise, Thursday is not a big problem.
I think how about 20?
20?
Yeah.
Okay. In a random sample of 200 shareholders of a company, 103 said that they wanted a change in the management. Find an approximate 92% confidence interval for the proportion of all stakeholders who want to change the management. Okay, fine. So let X be the proportion of shareholders who want to change. Okay. So proportion is 103 said that they want to change. So Q is going to be 97 said they don't want to change. Okay, for a 92% confidence interval, phi of Z is going to be 92, 100 minus 92 is 8, so this is 96, 0.96. Okay. 1.75. Z is 1.75. 92% confidence limits. So, plus minus 1.95. Okay, so it's going to be 103 divided by 200. Zero 0.515. 0.485. Yeah. 0.515 plus minus 1.95. 0.515 into 0.485 upon 200. This will give you the answer for the first part. Okay, na? Second part. State the probability that a 92% confidence interval does not contain P. Like 92% does not contain P will be 8%, which is 0.08. Are you getting it?
Yeah.
The probability that the 92% confidence interval will contain P will be 0.92 and does not contain will be 0.08. Still I'm checking it.
Okay.
We did 20. 0.08%. It's here. So we're done with this. In the next class, we'll do. I'll sort out. I've got 2 topical past papers of this topic now, so I will collect around 8-9 questions on this topic, and then after that we'll start with the hypothesis testing, inshallah. Okay, beta? Is this okay?
Yes.
Chal. Okay, Allah Hafiz. I'm sending you the file right now.
Okay.
The one which. Shall I send you this file as well, ye wali?
With the questions and
Do you have
answers, yeah,
this one?
yes. I don't have this one.
I had sent you. You don't have this one. You have the other one.
Yeah.
Okay. I'll send it to you as well. देखो अगर यहाँ से email के through if it's a longer document, it's a big document, it won't go. But I'll check if I can. What's your name, Sarah? Let's see. अगर जाता है तो अच्छी बात है. It'll go through email only. हाँ, it's gone. ठीक है तो ये हो गया और फिर मुझे ये वाला आपको भेजना है ना.
Yes.
So inshallah we'll meet on Thursday. You also
Yeah.
try and pick a few difficult questions.
Okay.
Chalo, Allah Hafiz. This one is too big, it's saying. Acha, haan, because, why is this big? Because of the 2 scanned pages which I have put in the beginning. Of Allah.
Okay.
Cannot bear with those. So I'm just getting rid of, I'm just keeping this patch here because this is useful for this class.
Okay.
Just this part. Okay? And the rest I'm deleting. Do you
Okay.
understand what I'm doing?
Yeah.
Chalo, okay, I'm just sending. You can leave. I am just